The last little bit in the electricity section would then be power and energy. And we have defined power in previous sections many times as power is the rate at which work is done. Remember, whenever there's a T at the bottom of the equation, you can say that it's the rate, and it's the rate at which work is done, or the rate at which energy is transferred. Now, changing this equation around, we get that W is equal to the power times by the time, and that's the equation that you will be getting on your information sheet as well. You get both. Now, if we look at this equation in a little bit more detail, you already know that voltage is the work done per coulomb of charge, or the energy transferred per coulomb of charge. So if I want to simplify this equation or change that equation, I could say that W then is equal to the voltage times by the charge, which here would give me VQ over T. And Q over T, rate of flow of charge, is current. So that gives me V times I. And that is where this first equation comes from on your information sheet. You are not asked to derive this, and then we can also use Ohm's law, and we can write it in this form. We can use Ohm's law again, and we can write the power equation in that form. So you get all these equations on your information sheet, and you just now need to know how to use these equations. The next thing is you must make sure when you read the question, are they asking you for the work, which is then going to be the power times by the time, or are they asking you for the power, which is the rate at which work is done? So then it's going to be the equations at the top. So read your question nicely, because to change the power equations to the work equations, you just add a T, but they are even given to you. So there's not much you need to learn here. The way they ask this often has to do with brightness. They will ask you about the brightness of a light bulb. And now remember, power is the rate at which work is done. So if the energy is sent to you faster in a shorter time, then you will see a brighter light. Or if more energy is sent to you per second, you will see a brighter light. So power is related to the brightness of the light bulb. Now, what they often ask is about series and parallel circuits. So what you need to know is if you are comparing two light bulbs with different resistances, and this is what the questions are often doing, and they say to you, this light bulb has a resistance of 5 ohms, and this light bulb has a resistance of 7 ohms. And without doing calculations, you must be able to predict which of these two light bulbs will be the brightest. Now you can reason it out. You can say, I have the energy coming from the battery. The same current will flow through both of these light bulbs. Because they each get the same current, it's going to be a little bit harder to move through this light bulb. So this one is going to need more energy. More energy in the same time will be a brighter light bulb. But if they say to you, use relevant equations to explain this, then you're going to have to go to your power equation. And because current is constant in a series circuit, the best equation to use here would be the power equation that has current in it. So if I can give you some advice, you go to the equation that says P equals I squared R. Because to talk about direct proportion, the extra thing in your equation must be a constant. So you can't say directly proportional if the rest is not constant. So I can say power is directly proportional to the resistance, but I can only do it because the current in the series circuit is constant. And now I've proven what I said before, because if the resistance is higher, the power will be higher, and therefore the light bulb will be brighter. But if I take those same two light bulbs and I now go and connect them in parallel, now remember, in parallel, the current is not going to be constant, because the 5 ohm resistor is now going to get a greater current. More electrons are going to go through there because it's easier. The resistance is lower. So this 7 ohm light bulb is going to get less current. So again, you can reason it out because you can say the voltage is constant, so they each get the same amount of energy, but more electrons or more coulombs per second will pass through the 5 ohm resistor, and less coulombs per second with the same energy will pass through the 7 ohm resistor, and therefore the 5 ohm resistor will be brighter. But again, if they ask you to use a relevant equation to explain this, now this time we've already said that the voltage stays constant. So the best equation to go and use when you are comparing the power of those two light bulbs will be V squared over R. Because I can say that power is now directly proportional to 1 over R, because I can say that the voltage is constant. So now, because the resistance is underneath the line, if the resistance goes up, the power is going to be going down. And we've reasoned it out and we've proven it mathematically now. So that's the first type of question you can expect about power and energy. And then they ask you about costing. So costing is the only place where we don't use the standard units. We normally work with watts and joules and seconds. But if we look at the power calculation, this is not given to you explicitly, but when you read the question, you will be able to see what you need to do, I'm hoping. Because they will say to you that we are paying Eskom for energy. Please remember this. Power is not what we're paying for, because power is the amount of energy per second. You're not paying for what you use per second, you're paying for all the energy. So power is the work over time, but we are actually paying for all the energy that we're using. So if you are looking at that equation, it's the work or the energy that we're paying for, and that's the power times by the time. Now, when we are doing these calculations, because of power being in watts being the answer is not going to be huge. So that's why we use kilowatts and we use hours rather than using watts and seconds, because otherwise your electricity bill is going to have a lot of zeros on it. So the power for the costing calculations must be in kilowatts, and the time must be in hours. And now you will see a kilowatt hour is then the unit of energy that we are paying for. So if you want to know what the cost is, you have to say, okay, I need to pay for all the energy that I've used, and I need to pay the amount specified on your bill. Say you're paying R1.50 per kilowatt hour, so you have to times that by R1.50 to get your cost. Now, the most important thing here is that, and we'll look at some past paper questions, and you should be all looking at past paper questions after this. You need to convert your energy into kilowatt hours. So whatever power was given to you in watts, you need to convert it into kilowatts. Whatever time was given to you, you need days or months or seconds, you need to convert it into hours. And then once you've got your kilowatt hours, you just times it by the cost, and that will give you your price that you have to pay for your electricity. And that's it for electricity.